day 5, we're going to take a look at functions and the notation. We're also going to take a look at domain and range and interval notation here. So the first thing we're going to review is the difference between a relation versus a function. A relation is any set of ordered pair. For example, you could have 3, 5, 4, 6, 8, 4, 3, 6. It's any sort of ordered pair. But for a function, every input has one distinct output. So if we look at this above, this relation here is not a function because 3 and 3, they go to two different outputs. And to be a function, every input has a distinct output. You guys might remember this as those function machines where if we input a 3 and out comes a 5, if we input another 3, a 5 has to come out as well. So to be a function, we'd have to have like 3, 5, 4, 6, 8, 4, and if there was a 3 again, a 5 would have to come out. We can't have anything different. Now one way to tell it from a graph is the vertical line test. So what the vertical line test is, it tells us if a relation is a function if a vertical line only intersects the graph once. For example, if we have a graph like this, we could draw in here and yes, this is a function. Whereas if we had a graph that looked like this, our vertical line intersects it twice, so no, it is not a function. Now you guys probably remember this, the domain is the set of inputs. We often think of this as the x values, the range is the y. And a nice way to remember this is if you write domain horizontally, range fits in there vertically. So domain are those x's, range are those y's. So here we're asked to identify the domain and range. So our domain here and our range. Our domain, the x values, we got 1, 2, 3, and 4. Our range would be those y values. 4, 7, 10, and 13. Well, is it a function? We could graph it, or we could just look. All of our inputs are different, so we won't have any repeating outputs, so yes, it is a function. Now this next one here, our domain, our x values 1, 2, 3, 3 again, 4. And our range, those y values, 4, 6, 8, 9, and 10. Well, right away here when looking through here, this 3 repeated, but it has two different outputs, so it is not a function. Now y equals x squared. If we remember how this is graphed, we have our parabola here. Oops, and it should hit right down here. It keeps going, so up and over, so the values keep going on there. So our domain, we could say, would be all reals. But our range, it doesn't go below the x-axis, so we could say y has to be greater than or equal to 0. The graph doesn't show it, but it does hit here, and it passes that vertical line test, so yes, it is a function. Now we're going to go over some notation here, and this might just take a little bit to get used to here. There's two different types of notation. Our first one we're going to look at is interval notation, and that uses these rounded brackets here when the value is not included. For example, if we had x is less than -3, we would write it with parentheses, -3, 3. So again, we don't use the inequalities, we're just using these round brackets. You use square brackets if it's included. So for example, if it's between -2 and 10, you'll notice we don't have the x there, but we just have the brackets and the rounded. In infinity, again, we use our infinity symbol, and negative infinity. So this is just if it goes on in the positive direction forever, if it goes on in the negative direction. So take a minute and pause this and try writing these in interval notation. Alright, so x is greater than 12, so 12 is our smallest, and it doesn't include it, so I'm going to put parenthesis 12 to infinity. Where on this one they are included, so we'll use those brackets, -4 and to +15. And one thing you'll notice, infinity always has the parenthesis next to it. So this one here, it doesn't include -2, but it includes 22. So we'll put a bracket there. Now, interval notation is one type, set is the other. And you'll notice set, we use those inequality symbols here, but you'll notice that we use these brackets. So it's x such that x is greater than or equal to 12. And it's saying the same thing, it's just a slightly different notation. And I have trouble with these brackets, so I always usually write it in interval notation or just with the inequalities, but you will see this from time to time. So set notation, it's x such that x is less than 4, and then we can close our brackets. And now we have something in interval notation, and we need to write it in set notation. So x such that -3 is our smallest. It could equal -3. So we have less than or equal to x, which is less than 3, and then we can close our bracket. Now we're going to see, what do you guys remember about asymptotes here? You might remember from last year, asymptotes are these lines that the graph approaches, but it never intersects here. So is this a function? Well, yes, it is here. But those asymptotes, it never crosses this line right here. So an asymptote is at y equals 2. And you'll notice there looks like there's another one here. I bet this is supposed to run right alongside. So there's another one at x equals 1. So let's see here. Is there an asymptote? Well, if we were to graph this, it's x squared but moved up 2. So no, there's not, because it keeps going on both ways. And there's no x equals, and there's no y equal because it doesn't approach this, so no. But how would you write the domain and range? And we're going to write it in both set and interval to practice. So our set notation, our domain would be parentheses x, and x could be anything, so we can say x, x, and what we say is an element of the reals here, because x can be any real number. And then our range, close this, see, it's a lot of symbols here, and our range in set notation would be y, and y has to be greater than or equal to 2. Now if we were to write this in interval notation, since our domain can be anything, we'd put parentheses -infinity to +infinity, and our range would be, it can include 2, so 2 to infinity. Now we're going to see if you guys can remember how to graph some stuff on your calculator here. So if we take our calculator, and I always graph in the scratch pad, and our first one was, let's see, make that fraction, 1 over x minus 2. So if we graph this, it looks like it runs right along the line y equals 0, but also at x equals 2. Let's see if I can make this okay. So it looks like it's crossing this one, but I think it's just running right alongside it. So here would be one, and here would be another one. So we have one at y equals 0 and x equals 2. And then we can go back and we can graph this other one. Again, tab goes up, and let's see, we could rewrite this as 2x minus 1 and x plus 1. Alright, so once again, it looks like we have one running right along here. So y equals 2 and x equals -1. And some of you might remember, for that vertical asymptote, we look in the denominator, and where that denominator equals 0. So you can see if we plugged in -1, we'd have 0, and 2 minus 2 is 0, and that makes sense. And for the horizontal, if you guys remember, we look at our degrees here, the powers here, and if they're the power on the bottom is bigger, it's at y equals 0. But if they're the same power, like these are both 2 to the first, we divide those coefficients, so it's 2 over 1. But if you don't remember that, don't worry, you can always take a look at your graphs.